What lies beyond the boundaries of the universe? This question itself is a trap, because the concept of beyond may not even exist. Scientists once used the most powerful telescopes to look towards the edge of the universe, 93 billion light-years away, and witnessed a chilling scene. Light was fleeing us at speeds exceeding the speed of light. This means that no matter how advanced human technology becomes, that light will never reach Earth. We are trapped. The universe is like a giant prison, and humanity can't even see where the walls are. Even more terrifying is the crazy hypothesis proposed by some physicists. Beyond the universe, there may exist an infinite number of parallel universes, each with another you are making different choices about, and these universes may be devouring each other at this very moment. Some have already perished, and some are being born. The one we live in is just one of countless bubbles that has luckily survived. But no one knows if another universe will crash into our reality the next second, turning everything to nothingness. But don't despair, because what's truly chilling is yet to come. Imagine you're on a spaceship, accelerating wildly in one direction, leaving Earth, leaving the solar system, leaving the Milky Way. Suppose you have unlimited fuel, unlimited lifespan, and your speed can approach the speed of light. The question is, can you eventually reach the edge of the universe? The answer might devastate you. First, you must understand a cruel fact. Everything we see is the past. When you look at the people around you, you're actually seeing them 3 nanoseconds ago. When you look up at Orion in the night sky, parameter 4, you're seeing them again. What you see is what it looked like 500 years ago, but by now it might have already exploded into a nebula. Even the sun, what you see is what it looked like 8 minutes ago. If the sun suddenly disappeared, the Earth would continue to orbit that void for 8 minutes before we realized the boss was gone. This is the cage of light, and it is speed this cage that determines how far we can see. The universe was born from the Big Bang 13.8 billion years ago. Logically, we can only see up to 13.8 billion light-years away, right? Wrong. Because the universe has been expanding and accelerating.
Those earliest celestial bodies that emitted light have been pulled to 46 billion light-years away by space itself in the 13.8 billion years that light has traveled. This is the radius of the observable universe, 46 billion light-years, with a diameter of 93 billion light-years. Within this range, there are approximately 2 trillion objects. Each galaxy contains an average of hundreds of billions of stars. Just imagining that number is enough to make one's scalp crawl. But here's a terrifying twist. Observable doesn't equal reachable. Suppose you actually embark on this insane journey, your spaceship accelerating at 10 meters per second. 10 meters per second the first second, 20 meters per second the next, and so on. After approximately 35,000 hours, you've passed the Moon once, then Saturn 11 days later, then Neptune 15 months later, and you've crossed your first light year. At this point, Einstein's ghost begins to haunt you. According to special relativity, objects with mass can never reach the speed of light. You can get infinitely close, but you'll always fall just short. That final 3 meters per second speed is insurmountable, even if you exhaust all the energy of the universe. It's like an invisible wall. Physics dictates, the law itself forbids you from crossing it. But the truly bizarre things don't stop there. When your speed approaches the speed of light, time begins to slow down. To observers on Earth, it's like watching a slow-motion video. But for you, time is normal. Even more absurdly, you'll find that time in the outside universe seems to be fast-forwarded. On October 15, 1991, scientists detected a cosmic ray called the Otena particle. This particle's speed is infinitely close to the speed of light, and it carries the energy equivalent to a baseball traveling at 100 kilometers per hour. Imagine a particle smaller than an atom possessing the kinetic energy of a baseball. Even more astonishing is that due to the time dilation effect, for this particle, it only took less than 5 minutes to travel from the Andromeda galaxy 2.5 million light-years away to Earth. For us, that's 2.5 million years. What does that mean? If you were traveling at near the speed of light, theoretically you could traverse the entire observable universe in your lifetime. But the price would be that when you look back at Earth, billions of years might have passed. The sun would have long since died out, and all traces of human civilization would have vanished. You would become the loneliest wanderer in the universe. But an even more despairing reality awaits you. After traveling more than 8.3 billion light-years, an invisible red line awaits you. Once you cross this line, you will never return. It's not because of insufficient fuel or technological limitations, but because space itself is expanding at a speed exceeding the speed of light. The region of space you are in is moving away from Earth at a faster-than-light speed. Even if you accelerate back at full, it will be like rowing speed against the current, getting further and further away. This isn't a bug in the laws of physics. Rather, it's a hard boundary set for us by the universe. In 2024, the Dark Energy Spectroscopic Survey released a discovery that shocked the scientific community. Dark energy, which drives the accelerated expansion of the universe, may be weakening over time. What does this mean? No one knows for sure. Perhaps the fate of the universe is more bizarre than we imagine. Now let's stretch the timeline. Suppose you continue your journey. When the clock on your spaceship runs for 200 years, 10 to the power of 41 years have passed in the universe outside. This is a number with 1 followed by 41 zeros. At that time, all stars will have burned out, all black holes will have evaporated, and there may not be a single particle in the universe except for your spaceship. You will drift forever in absolute darkness, without direction, without destination, without end. So, can you reach the boundary of the universe? The answer is yes. The end of the universe will be faster than you reach any boundary. But that's not all. All of the above deductions are based on the assumption that the universe is flat. According to current observational data, the universe is indeed almost flat, with a curvature close to zero. But what if the universe isn't flat? Einstein's theory of general relativity tells us that the universe might have 3 shapes. The first is positive curvature, like a giant sphere. If you keep walking in one direction, you'll eventually return to your starting point, just like walking on the surface of the Earth. This kind of universe is finite but has no boundaries. Einstein called it finite unbounded. The second is negative curvature, like a saddle surface. In a saddle-shaped universe, if you walk out of one pentagon, you'll return from the opposite pentagon and see the same starry sky. This means that the distant galaxies we see might just be mirror images of the same set of galaxies from different angles. You think you're looking up at infinity, but you're actually just looking in a mirror. Finally, let's return to that unsettling question from the beginning. What lies beyond the universe? According to the theory of the eternal universe, explosion, our universe might just be one of countless bubbles in the universe. Each bubble is a product of a Big Bang, with different physical constants, different dimensions, and even different time flows. These bubbles float in a higher dimensional hyperspace, constantly being born, expanding, colliding, and dying. We cannot see them, touch them, or even prove their existence. The speed of light might be a different number. Atoms might not even exist, and in some bubble, even the concept of time might not even be meaningless. Our universe is just one of countless possibilities, a chance physical constant that just happens to allow stars to burn, just happens to allow carbon to form, just happens to allow life to be born, just happens to allow you to see this text at this moment. Change the parameters, and everything will cease to exist. So, what lies beyond the universe? Perhaps it is endless nothingness. Perhaps it is another existence we can never understand. Perhaps the concept of beyond itself is wrong because the universe contains everything, including space, time, and even the concept of existence itself. But one thing is certain. We are trapped in this bubble 93 billion light-years wide, never to escape. And this bubble is getting bigger, emptier, and darker at an unstoppable speed. This is our universe, a beautiful prison, a grand loneliness, and we are the only prisoners who know we are trapped. But then again, perhaps it is precisely because we know the existence of boundaries that we should cherish this moment even more. After all, in this vast universe, being able to contemplate the meaning of the universe itself is the most incredible miracle.